Let's start with something familiar. The Boeing 757 cruises at about 525 miles per hour. This is the same aircraft you board without thinking twice. You settle into a seat, maybe watch a movie, yet outside that window you're moving faster than most storms on Earth. What makes it fascinating isn't danger, it's normalcy. Hundreds of people, thousands of parts, and decades of engineering working together so smoothly that extreme speed feels boring. Metal wings slice through thin air while engines push with controlled violence, holding an entire city's worth of weight above oceans and mountains. This is where human speed becomes invisible. We mastered flight so completely that half a thousand miles per hour feels ordinary. But once engineers realized humans could live comfortably at that velocity, the question changed. If this feels slow, how fast can we really go? And that curiosity didn't stay in the sky. Instead of flying higher, engineers looked down at the road and asked a reckless question. What happens if a car tries to outrun sound itself? The answer was Thrust SSC, a machine that looked less like a car and more like a missile with wheels. Powered by jet engines, it thundered across desert ground at 763 miles per hour, officially becoming the first land vehicle to break the sound barrier. At that speed, the Earth stops feeling solid. Air pressure builds, shockwaves form, and even tiny steering corrections matter. One mistake wouldn't just slow the run, it could end everything instantly. What makes Thrust SSC incredible isn't just speed, it's control. Engineers turned chaos into precision, proving that humans could dominate not only the sky but the ground itself. But once sound was beaten on land, the next leap was obvious. The sky was waiting. Now the air begins to thin and speed stops being comfortable. The SR-71 Blackbird cruised near 2,200 miles per hour, fast enough to outrun threats chasing it. Instead of fighting danger, it simply left it behind. Built from titanium to survive extreme heat, the aircraft actually expanded as it flew. Its skin grew hotter than an oven. Fuel leaked on the runway before takeoff because the body needed heat to seal itself properly. Everything about it sounded impossible, yet it worked. The Blackbird didn't rely on weapons. Its defense was velocity. It moved so fast that interception became pointless. Radar saw it, missiles launched toward it, and seconds later it was already gone. Humans had learned something new. Speed itself could become protection. But even this wasn't enough. Engineers wanted to know what happened when aircraft stopped behaving like airplanes altogether. The North American X-15 wasn't chasing records. It was chasing the unknown. Strapped to a rocket engine, this experimental aircraft blasted to about 4,520 miles per hour and climbed toward the edge of space. Pilots weren't just flying anymore. They were transitioning between aviation and astronautics in a single mission. Up there, air barely exists. Control surfaces lose effectiveness. Gravity feels different. The X-15 forced humans to relearn flight from scratch. Every mission answered questions nobody had faced before. How do you steer when air disappears? How do materials survive hypersonic heat? How does a human react when Earth begins to curve beneath them? The lessons learned here quietly built the foundation for everything that followed, especially vehicles that would move faster than anything with wings. At around 13,000 miles per hour, the DARPA HTV-2 stops feeling like an aircraft at all. It becomes a flash. Designed as a hypersonic glide vehicle, the HTV-2 raced along the edge of space at speeds comparable to a falling meteor. Air friction turned surrounding gases into plasma, a glowing envelope hot enough to challenge electronics, sensors, and communication itself. guiding something at this speed is like steering lightning. Traditional aerodynamics begin to fail. Heat attacks every surface. Signals struggle to survive. The HTV-2 proved humanity is entering a new era, one where vehicles travel so fast that the old rules of aviation simply no longer apply. And once you reach those velocities, returning home becomes its own battle.
30 seconds until touchdown.
The space shuttle slammed back into Earth's atmosphere at roughly 17,500 miles per hour.
Main gear. Landing gear now down and locked.
At that velocity, air behaves almost like a solid wall. Compression alone generates temperatures capable of melting steel.
Nose gear touchdown.
Thousands of heat-resistant tiles protected the spacecraft, with each one critical. You lose too many, and survival becomes uncertain. Pilots weren't flying a powered aircraft anymore. They were guiding a falling spacecraft that had one chance to glide correctly. Too steep and heat overwhelms the ship. Too shallow and it skips back toward space. It's controlled chaos. A balancing act between speed, gravity, and survival. Yet even that pales compared to the returns from the moon. When Apollo 10 returned to Earth, its command module hit about 24,791 miles per hour, the fastest humans have ever traveled. At that speed, re-entry becomes an encounter with pure energy. The capsule streaked through the atmosphere like a comet, wrapped in fire created by its own motion. Unlike the shuttle, this spacecraft relied on simplicity. A blunt shape, a powerful heat shield, materials designed to burn away layer by layer, carrying heat with them. Inside sat astronauts trusting chemistry, physics, and engineering completely. Survival depended on calculations made years earlier, executed perfectly in minutes that felt eternal. Humanity had now reached speeds once reserved for celestial objects.
Roger, Houston, we are returning to the Earth. Over.
The next step was obvious. Leave humans behind and go even faster.
A journey lasting nearly 10 years, traveling over 3 billion miles.
New Horizons launched not just to travel far, but to arrive within a human lifetime. Moving at roughly 36,373 miles per hour, the spacecraft raced toward Pluto, shrinking billions of kilometers into a manageable journey. Alone in deep space, it carried cameras, sensors, and humanity's curiosity into regions never explored up close. There are no repair crews out there, no second chances. Every command must work after years of silence. New Horizons transformed speed into discovery. Because of that velocity, we saw Pluto's mountains, glaciers, and strange atmosphere instead of waiting generations. But even this incredible pace would soon look slow compared to humanity's boldest mission yet.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
The Parker Solar Probe doesn't chase planets. It dives toward a star. Reaching about 430,000 miles per hour, it is the fastest human-made object ever created. Gravity from the sun slingshots the probe to unimaginable velocity as it plunges closer than any spacecraft before it. Here, heat and radiation reach brutal levels. A carbon composite shield protects delicate instruments hiding in permanent shadow, measuring solar winds and magnetic forces that influence the entire solar system. This mission isn't about speed for spectacle. Speed is survival. The faster it moves, the less time extreme heat can attack the spacecraft. And in doing so, Parker's Solar Probe reveals something profound. Humanity didn't just learn to fly, drive, or orbit. We learned to run alongside a star.
All 3 RS-68 look good in the full thrust mode. Response looks good.